Hey everybody, this is Mr. Beckstrom. Today we're going to go over section 3.1. This is on angle measurement. So the first thing I want to talk about is how we identify an angle. And there's usually three different ways that we can. So the first way is if we have some point on one side or ray, and we have another point on the other side or ray, like A and C, and then we have a point here at the vertex. The vertex is where these two lines intersect. We can describe that angle as either ABC or CBA. Either one of those, as long as the vertex value is in the middle of those three letters. The next way is if you just have a letter down here at the vertex only, you can just say this is angle D. This is angle D, and this here means the measure of angle D. And then we can also put a letter. A lot of times we'll use different Greek letters, including alpha and theta, inside the angle. And that's the same thing here. This means the measure of E here, where E is the angle there. So here's three different ways we'll see it, which can really get confusing. So I just wanted to make sure I touched on that before I moved on. And then I want to take a look at how we can use a protractor in order to measure an angle. So the first thing we really need to know is a right angle, which is a 90-degree angle, is one where the two rays will meet perpendicular. That means they'll meet straight up and down from each other. In this case, if you were to lie one side flat, the other side would be straight up and down. Anything greater than that 90 degrees, larger, is going to be obtuse angle. Anything smaller than that is going to be an acute angle. And then if you're just going to use this ray here on the bottom and this ray, so we're to go in a complete half a circle, that's called a straight angle, which is 180 degrees. So notice that you see on the top here it goes from 0 to 180, but then on the bottom it goes from 0 to 180 down here. And this depends on which side we're using for our main side, for our starting side. So for example, if I were to use this left side here as my starting ray for my angle, then I'm going to use this upper set of values up here to determine what the measurement is. So for example, if I had, let me kind of write this out a little bit. Let's say I was working with this angle right here. Since I went to the left here with this ray, then this angle here, I'm going to look up here. So really this is right, my red line didn't quite touch it, but it's right between 40 and 50, so that would be a 45-degree angle. Now let's say I did this. Oops. I started here and I went up there. Notice that this measure here is greater than 90 degrees, so we're using the upper numbers here, so that would be a 120-degree angle there. And then I can also use the right side here to start my angle. Let's say I did this angle here, then I'm going to use the lower values there, so that would be a 60-degree angle right there, and so on and so forth. So the two sets of numbers are just depending on whether or not this starts to the right or to the left. And one easy way to remember it is that if your angle is less than 90 degrees like this one is, we can't use the 120 up here. So that means that we know that we need to use the 60 degrees. All right, let's move on. All right, now let's say we have two lines that are intersecting like these two are here. So this here would be the vertex of really four different angles, right? So we have this angle that's kind of facing up, this one that's down, this one that's to the right, and this one that's to the left. So the one to the left is A, the one down is D, the one to the right is C, and the one up is B. So we have some properties about these that I want to go over. And the first thing is we can talk about vertical angles. So vertical angles are the ones that are opposite from each other. So A and C are vertical angles, and D and B are vertical angles. And vertical angles equal each other. So C is equal to A and B is equal to D. And so if I knew that C was, for example, like 37 degrees, then I would know that A is also 37 degrees. Now, the adjacent angles always add up to 180 because they make a straight angle. So C and B add up to 180. C and D add up to 180. A and D add up to 180, and A and B add up to 180. So if I were to know what C is, let's say C was equal to 37 degrees. So let's say, oops, make sure C is equal to 37 degrees, and I wanted to know what B was. B is equal to 180 degrees minus 37 degrees, which is equal to, that would be 143. So this B is equal to 143 degrees here. All right. And the next thing I want to talk about here is if we take a set of parallel lines, those are lines that will never touch each other because they're always the same distance away from each other. And then I took a line and crossed it through those two parallel lines. That's called a transversal. We have a bunch of properties about this as well, kind of similar to the last ones. And that is, for example, F and B here, notice that they're both kind of in the same position, and those are called corresponding angles. So F and B are corresponding angles, E and A are corresponding angles, G and C are corresponding angles, and H and D are corresponding angles. And corresponding angles are always equal to each other. So that's kind of a nice property that we have about that. And we're also going to have alternate interior angles. So that would be C and F. They're the interior ones. That means they're kind of in the middle of these two parallel lines. So C and F, but they're alternating. Those are also equal to each other, as well as D and E. D and E are also equal to each other. And we can use these in order to solve some problems. Let's take a look at an example using the idea of corresponding angles, alternate interior angles, vertical angles, and supplementary angles, the ones that add up to 180, and see if we can solve this next one. All right, here we have a set of parallel lines, and then we have a transversal that intersects those two parallel lines. They give us this single angle up here, that this is 70 degrees, and they want us to find all other 7 angles there. So go ahead and pause the video, see how far you can get using all of these ideas that we had, and then we will go ahead and walk through the solution. All right, so go ahead and pause now. All right, so there's a lot of different ways we can start here, but one thing I know from the first set of angles I looked at was that opposite or vertical angles are equal to each other. Let me just, so I know that this here also has to be equal to 70 degrees. I also know that corresponding angles, the angles in the same positions here, also have to be equal. So this is also 70 degrees. And because W is corresponding with S, this is also 70 degrees. Now, there's lots of different ones I could do next, but I know that P and R are adjacent angles, and they have to add up to 180. So P is equal to 180 minus 70, which is 110. So that would be 110 degrees. And then Q, since it's a vertical angle with 110, also has to be 110. U is corresponding angle with Q, so that also has to be 110. And T is a vertical angle with U, so that also has to be 110. So we'll see that we'll have two distinct values here, 70 and 110, which for almost all of these we're going to have two distinct values, except for when the transversal is perpendicular to the parallel lines. Then we'll have all 90-degree angles. All right, let's move on. And finally, let's see if we can solve this problem here. It says in the pipe flange shown below, the 6 bolt holes are equally spaced. What is the spacing of the holes in degrees? So I'll give you one hint before you try this. Remember that a complete circle is 360 degrees. So go ahead, pause the video, see if you can solve that, and then we'll walk through the solution. Alright, so I'm going to draw this kind of from a top-down position here. Let me go ahead and, oops, draw a circle. Something like, it didn't do it. Let me try it again here. Do I have empty shape? I do. I guess that was just a horrible circle that I drew. There we go. There we go. Now I have 6 holes there. So I have like 1, 2, and then probably like 3, 4, 5, and 6. And it says that they're all equally spaced from each other. Turn that back off. So if I go from the center here, I'm going to have it looks like I'm going to have 6 angles going out from the center to these holes here. All right, and I know that they're all equally spaced, so they all have to be the same measure since they're equally spaced. And I know that they all have to add up to 360 degrees. So really I have x plus x plus x plus x plus x plus x is going to be equal to 360 degrees. I can combine all of those x's there, so I'm going to have 6x is equal to 360 degrees. And then I can divide both sides by 6. And I'll have x is equal to 60 degrees. So that is the degrees between each one of these holes there. All right, guys. I hope this helped. If you have any questions, please let me know, and I hope you have a great rest of your week. Thanks.